Hey, Mr. Estrada here, and today I want to talk to you about reflection. So our learning target says I can reflect points across a given line in the coordinate plane. So I want to begin by first showing you a reflection. Okay, so here we have an animation that comes to us via the good folks at deltamath.com. You'll see the figure on the left, the pink figure, is being reflected over the line x equals -3. So this is the line x equals -3 here. And just, notice what happens. The figure gets reflected over the line. Notice that the size of the figure does not change. And a reflection is essentially a flip. So let me give you a formal definition here. A reflection or a flip is a transformation in which a figure and its image have opposite orientations. So here we have the letter F, and the letter F is being reflected across this line over here, and it produces the image that we see right over here on the right. The original points are labeled A, B, and C. The reflected points, usually they'll get called A prime, B prime, C prime, or in this case A1, B1, C1, to distinguish the reflected points from the original points. Okay, so here our first example says if point P, 2, -1, is reflected across the line y equals 1, what are the coordinates of its reflection image? So it's showing the reflection already. Let me get rid of it, and I want to show you how you get it. So here we got point P. The coordinates are 2, -1, so point P is right over here, and we have the line y equals 1. So the line y equals 1 is the pink dotted line that you see here. And it says that the point P is reflected across this line. So if you actually want to perform a reflection, the way I do it is I count how far the original point is from the line of reflection, and then I'll just reflect it the same distance on the other side of the line of reflection. So here's point P. Let me show you what I mean. Point P is 2 boxes away from the line of reflection. So I'm going to count 2 boxes from the line of reflection on the other side, and that will give me my new point. So that's 1, that's 2. So the new point P, or P prime, should be right over here. So there's my new point, P prime. And the coordinates of P prime are 2, 3. So if you just want to reflect a point, all you have to do is just really count how far the point is from the line of reflection, and then count the same on the opposite side, and it'll reflect the point. Example 2 says, reflect triangle ABC with coordinates A -1, -2, B -2, 1, and C -1, 3 across the y-axis. So here's the y-axis, and this time we're being asked to reflect a triangle. And I'm going to essentially use the same process that I used in our first example, and I'm just going to reflect the figure point by point. So I'm going to begin first with point A, and I'm going to count how far point A is from the line of reflection. So the y-axis is the line of reflection. Line of reflection. That's what the y-axis is. So if you want to highlight it, you can. Let's go ahead and do that. Let me see if I can just get a dotted line here. All right. So the y-axis is the line of reflection. All right, so let's reflect point A. So point A is one box away from the line of reflection. So A prime should be one box away. So here is point A, and here is A prime. So let me just write A prime there. A prime. Point B is two boxes away from the line of reflection, correct? 1, 2, so I count two boxes on the other side. 1, 2, so point B should be right over here. And point C is also one box away from the line of reflection, like A, so I'll count one box away on the other side, and that will give me C prime. So here is my reflected figure. And again, notice the size does not change. The only thing that changes in a reflection is the orientation. So the coordinates of A prime are 1, -2. The coordinates of B prime are 2, 1. And the coordinates of C prime are 1, 3. And you always want to state the new coordinates. Let's try another one. Reflect the triangle ABC with coordinates -2, -1, B, 0, 1, and C, 3, -1 across the x-axis. So here is my line of reflection, right over here. It's the x-axis this time. So again, it's the same process, so just count how far the original points are from the line of reflection, and then plot that same distance on the other side. So here's A, so A prime should be here. And B is one box away from the line of reflection, so I'll plot a point one box from the line of reflection on the other side though, so B prime will be right over here. And C prime would be right over here. So here is what my reflected figure looks like. You'll notice that the figures are overlapping, and the reason why the figures are overlapping is because the figure is on the line of reflection. So here are my coordinates for A prime, B prime, and C prime. All right, so you might have noticed that when you reflect across the y-axis, the sign of the x-coordinate changes. And when you reflect across the x-axis, the sign of the y-coordinate changes. So why don't we go ahead and use those applications that we might have noticed for this problem here. It says reflect parallelogram A 20, B 03, C 3 -3, D 50 across the x-axis. So using these rules, the one that applies for us is this one right over here. When you reflect across the x-axis, the sign of the y-coordinate changes. So that means A prime will be 20, right? The sign of 0 doesn't have a sign. So you're just going to get 20. B prime would be 0, -3. C prime is 3, 3. And D is 50. So when you actually sketch those points, you get a figure like this. All right, you're going to notice something here. The points, 2 points remain invariant. And that's just a fancy word for 2 points remain the same. So it's just another word for the same. Essentially what it's saying is that A and D do not change. And the reason why they do not change is because A and D are on the line of reflection. All right, so to finish up, when a figure is reflected, the size does not change. If you reflect a point that is on the line of reflection, the point will remain invariant. So just remember these facts and all the other stuff we talked about in this video, and you should be fine for tomorrow's class. Hope this helps. Have a great day.